Hi, welcome back. In today's video, we're going to be drawing a hypocycloid in AutoCAD. Now, for some of you who might not know, a hypocycloid is the curve that is traced by a point on the circumference of a circle rolling inside of another circle. So a circle rolling inside of another circle. All right, and you'll see what exactly that means as we go progress during the video. Now, in order to get things going, let's first break down our question here. Now our question reads: hypocycloid, draw locus of a point on the periphery of a circle which rolls from the inside of the curved path. So this is the total opposite of the epicycloid that we did before. Now it says take diameter of rolling circle, which is 50 millimeter, and radius of directing circle 75 millimeters. And this is exactly similar to the hypocycloid. We're utilizing the same numbers to make things a bit easier. Alright, now I don't remember the calculations that I did. Alright, so we'll redo our calculations here based on what is given here and our formula that we have here to our left. Alright, so let's go ahead and calculate those. Let me pull up my calculator. Alright, now it says that the angle of the directing circle, in order to find that, you'll need to utilize this formula here, and this formula says that theta, which is the angle, is equal to r, small r, which is the radius of the rolling circle, divided by the radius of the directing circle, multiplied by 160 degrees. Alright, so what is r? That's small r. Small r is the radius of the small circle, which is the rolling circle. Now this is the diameter, so it means that the radius is going to be 25, and we're going to divide that by the radius of the large circle, which is 75 millimeter. Alright, so we have done that. Now we'll get this value here, 0.33. Alright, then we'll multiply that value by 360 degrees, and we will get an angle of 120 degrees. So the angle of the directing circle, let me see if I can write that one in text. Drop down here, multi-line. Alright, let's write it here. Angle of directing circle is equal to 120 degrees. If you want to put the degree symbol, you can go here where it says symbol, click the drop down menu and select this one that says degree, and you'll get the symbol there. Let me change the text height of this to 6. Alright. Alright. Now, once that has been calculated, we're basically good to go. Alright. And remember, whenever it's going to be rolling, the distance that it will be covering, so the wheel here, when it makes one complete rotation, that will be equal to the circumference of the circle or the wheel. Alright. In order to find the circumference of any circle or circular object, then you're going to use the formula pi d, which is pi multiplied by the diameter. Let us calculate that one there. So, and we'll need these numbers to cross check to ensure that we haven't made any mistake. So I'm gonna, pi is 3.14 multiplied by the diameter. Diameter is 50, which will give us 157 millimeter. 157 millimeter. So let's add it here. Alright, drop down. What did we just, the length, the length of the directing arc, that's what I'm going to call it, is equal to millimeter, and I'm going to change this to arc as well. Arc. Alright, so those are the value that we will get. Alright, so we're going to start things off similar to how we did the epicycloid, where we're going to start with our directing circle. Alright, now our directing circle, in order to create our directing arc or curve, we're going to use our art tool here. I don't remember which one I had used, but any one of these can work. Let's start with this one here that says center start angle. So I'm going to go here and just click at a random spot. Alright, then I'm going to enter the length of the directing circle, which is 75. Then I'll hold down shift and select my greater than symbol. Then I'll enter the angle of 120 millimeters. 120 degrees, sorry. 120, enter. Let me just go 120 again, because that 120 selected something else. Alright. Now this curvature here should have an angle of 120 degrees. In order for me to find that out, I'm going to work a bit of magic here. Let me turn on my O snap and ensure that endpoint is turned on. Click here to there, then back here, and let's do some measurement check. So let's go here, then go to align. Let's check on that one there. Let me turn off ortho for this. Yes, that is 75. Let's check the angle. Yes, it's 120. Alright. And let's check on, let's see the length of this here. Let's go here. Alright, that is equal to 157. Excellent. Alright. So now I'm going to simply rotate this so that it looks a bit better. Alright. And let me just move it up a bit. Alright, right about there. Alright. So now we're going to focus on this right here. Alright, let me place things that need to be on their respective layers on those. So those are going to be dimensions. We're going to need them. This here and this here are going to be construction. I hope you can see that brown line there. Let me see if I can zoom in a bit more. Alright. Alright, now the next step that I'm going to do, now for the epicycloid, remember the wheel had roll on the outside. In this one, the wheel is going to roll on the inside. So you would probably remember I had offset this line here outwards by a certain amount. This time we're going to offset it inwards. We're going to offset it 2 times, if you want to think about it like that, by 25 millimeter, which is basically the radius of what? The small rolling wheel. So I'm going to offset it by 25. So let's go. O, enter, then enter the number 25, then press enter. O is the shortcut for offset. Click, inwards like that. Click again, inwards like that. Alright. Once that has been done, we're pretty much set. Alright, now the next step for me is to draw my rolling circle. I'm going to click on the circle command or type C and press enter. I'm going to click right here at the end of this middle line here and then open my cursor to that point there. Now all of these points that I have here has names. Believe it or not, they do have name. Let me change the color of this so things are a bit different so you can see the difference of what is going on. Alright. Now, the next step for me is that I'm going to label some points. Alright, let me go ahead and label some points. Place them on that layer there, multi-line. So I'm going to label this intersection here as O. Alright, I'm going to label this point here, the center of the circle, as C. And I'm going to label this point here where the circle is on this line here as point P. Alright, now we'll start things off there. The next thing I'm going to do from at this point now, I'm going to move this here, this dimension here, and put it on the other side. Go here, align here to here. Alright, that's on our dimension there. Alright, so you see this circle here, let me put it on our object layer. I'm going to be dividing this circle into a number of equal parts. The number of division is up to you. You could make it 4, 6, 8, 10, 12, it's up to you. Alright, the more points you have, the smoother your curve. I'm going to divide my line into 8, or my circle into 8 equal parts. Let me switch the color. Let's keep it on white for now so you can see. Alright, now once I've drawn that line from point C to point P, I'm going to, that's not where it's supposed to be, right there. Alright, I'm going to now use this line and I'm going to utilize it to divide our circle into 8 equal parts. So from here now I'm going to select that line, click on the drop down menu for array, find polar array, and click at point C right here. Automatically it's going to divide your circle into 6 equal parts. What you can do from here, if you want to do 8 like me, you simply go up here where it says items and change that 6 to 8 and press enter. Alright, that will divide your circle into 8 equal parts. Alright, now from there, because I want you to remember that this is the directing curve that it's going to be rolling on. So you can see it's going to be rolling on this here. Alright, on the bottom side. Alright, so I'm now going to label the divisions on my circle. Alright, I'm going to be labeling the divisions on my circle. P is going to be right here. My apologies. P is right there. Alright. Then now, you can now label these points. You could start from here, 1, 2, 3, all the way around, and so on and so forth. Here I'm going to just make, let's see if I can, 1, and then copy this around. So copy it. 2. Let me turn off ortho for this, not ortho but OSnap, and place it here, or 1 there, 1 there, 1 there, alright, and 1 here, 1 there, and here. Alright, this is 8, so this is going to be 7, should be 7, 7, 6, 6, 5, alright, 5, 4, we're halfway there, double tap on this one here, 3, double tap on this one here, 3, 2, and then 1. Alright, so now that we have labeled all our division points, the next step for us, alright, I hope everybody is seeing this clearly, or maybe I should make things a bit less complicated. Let me see if I can turn off the dimension there for now. Alright, what I'm going to do now is that I'm going to be drawing some circles from point O right here to each one of these division points on our circle. So I'm going to go circle, find the center of this here. Let me see if I can find OSnap, turn on, click in the center there at O, and then move my cursor to either 3 or 5, because the 3 and 5, this circle will pass through both of them. Alright, I'm going to do another circle, so C, enter, and from the same point O, I'm going to make my way to point 2. Point 2 circle will also pass through point 6 circle. I'm going to repeat the process from O to point 1. Point 1 circle will also pass through point 7 circle. And then finally, A, which is also P, that circle is already there, or that curve in the form of this one here. Alright, from there now I'm going to be trimming up my drawing, or cleaning up, by simply using this circle as a cutting plane and this circle, and this line rather, as a cutting plane. I'll type TR and press enter, and then I'll select these lines here, and it will get rid of everything down below. Alright, now once that has been done, the next step for us to do is to place, or we're going to be dividing, we're going to be placing division points on our curve here. Now, how many division points? It's going to be the same number of division points that you did for your circle. So if we divided our circle into 8, it means that we're dividing our curve into 8 as well. So if we go, click on, type div on your keyboard and press enter, that will activate your divide command. Click on that green line there and press 8. Enter. By default, you're not going to see anything happen. I want to type this letter PT. Press enter now. This window will pop up. Switch to any one of these other symbol here. I'm going to use the X. I'm going to change things to absolute and then change this to probably 1. Alright, then I have some division points now. From here, I'll simply draw lines from each division point, so from here to here, then back to here. I'll do the same here as well, here to here, and then back to here. Alright, reactivate my command again from here to here, and then back up again, and then finally from here to here. Alright, now something else I want to know. We're going to do some more labelings, and we're going to be labeling every point, everywhere that these lines, that's these lines here, intersect with this C center line here. Alright, all of them are going to be called C, all of them. So we're going to have this first one here is going to be C1, this one is going to be C2, that's right here, C3, so on and so forth. So let me copy point C here, and I'm going to place copies. Right, first one is going to be here, then here, 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 here. So that's the center in which, or that's the part in which the center of the circle will remain as it's moving through its rotation. So as it's rotating, the center will not change in terms of like where it is rolling. It's going to remain in the center there. So this is center 1 or C1. Click on that there. This is center 2, C2. Oops. Then we have center 3. Alright, right there. Center 4. Alright, we're at center 5 now. And then center 6. Select the 6 and then switch to this. Now we're at center 7. Center 7. Finally, we're now at center 8. So we're at center 8 now. Alright, excellent. Now, once we have all of those in place, it's time for us to now start plotting the points that our locus is going to pass through. From that, I wanted to start things off by creating a circle. Create a circle by typing C, press enter, and I want to make the radius the same as this one here, which is 25. Alright, now this circle here, this circle is going to, and let me switch the color to something else. That is, you know what, let me use this orange color here. So this center here is going to be moved through all them, C1, C2, C3, 4, similar to the epicycloid. Alright, let me kick things off at C1, wherever orange line intersect with the dividing line, so that's right there. Alright, now how are we going to know where the points are going to fall? Alright, now by default our first point is going to be at point P right here. Alright, our second point is going to be on this number 1 line here. How are we going to know where on this number 1 line here is going to be? Anywhere this circle intersects it, alright, that's where the point is going to be. So here's where it intersects, so another point is going to be where? Right here. Alright, then now we can move this circle to C2, and then now we can move to our number 2 line. Here is our number 2 line. Where is it? Right here. Alright, our number 2 line is this here. And where are we going to place our point? Anywhere this orange circle intersects with it. Now I know things are a bit confusing now with the lines, but let me see if I can clear things up for you. Alright, that there, let me put it on another layer. So things are less crowded. Alright, so I hope you can see it a bit better now. Alright, so less bright colors. So we're now at C2, center 2. Alright, so let's find our 2 line right here. Where does the two intersect? Right here. Alright, it also intersects over here, but we're moving from this direction, from the left to the right. So we're focusing on this point. Once we get to the halfway mark, then we start focusing on the right side of the curve or the circle. Alright, if that makes sense. Alright, so here, let's place another point right here. Alright, so let's now move to C3. When we're at C3, we're now going to move to 3 line. Where's 3 line? Right here. Where the 3 intersects with the circle? Right here. So we add another point there. Now we're at where? C4, which is the center or the halfway mark. So by default, where things are, that point is going to be smack. That's not where it should be. Let me double check on this here. Is it no? Yeah, right. So it's not in the center, and I picked up on that early. So point is going to be right here. All right. Next thing I'm going to do now is move from C4 to C5. So I'm at C5 now. All right. Now let's find our number 5 line, which is right here. Where does it intersect? It intersects our 5 line right here. All right. So let's place a point there. Point. Right. Point. Let me just double run that again. Point, which is going to be 5 line right here. All right, it didn't go where it's supposed to go. It's right there. Now we're going to move our circle to point our C6. So C6, and let's find our number 6 line, which is where? Right here. Where do they intersect? They intersect right here. Alright, so let's place a point there. Alright, now let's make our way to where? Point 7. We're almost through. Now, where does it intersect your 7 line? Here is your 7 line right here. Let's make our way around. Here's where it touches. Right there. So let's place our point there. Alright. And then now, finally, move our way or make our way to C8. Alright, my C8, and where does it intersect? By default, right here, because this is our C8 line. C8, which is point P, that's where things end. So let's add a point there to close things off. Alright, now from that now, you can now draw your locus of your point. So I'm going to go to my object layer here, go to the draw tab here, click on this drop down menu here, and then click on spleen right here. Then I'll start at this point here, which is P1, make my way to P2, and just simply move through all those points that I've created. Alright, just like or similar to the epicycloid or the cycloid that we would have done. Alright, enter on your keyboard and let's see how things look. So this is the curve of the locus point of point P here as it rolls where on the inside of this curvature here. Alright, so let me now clean things up by placing things that should be on the relevant layer on those layers. So all of this here, construction, 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 all of this is construction. The only thing that is going to be bold is going to be your circle and your locus point. All right, and remember we're going to label these points, so it's P1, P2, P3. So P1, let me undo that, turn off O snap. P1, 2, 3, 4, 5, 6, 7, and then finally that would be P8. Let me go through and edit these. So P8, highlight down there. P7, highlight down there. Alright, this one here, P6, P6, let's select that one there, dot. This one here, P5. Alright, so everything is kind of corresponding in terms of like the numbering and the lettering. P is for points, so we're at P4 now, which is the halfway mark. Making our way to P3. 3. Alright, we're at P2 now. And then finally, we move on to P1. So we're at P1 now, finally. Alright, so what is missing now? Alright, dimensions. Remember, you must always dimension your drawing because you're losing valuable marks if you don't add those marks. For your plane and solid geometry, I think dimensioning alone is about, I don't remember, but it's a lot of marks, a lot of marks. Alright, so when your moderator and your teacher is marking, they can't mark you for what you don't have. So if you don't have any dimension, you can't get marks for that. And if your teacher gives you marks for dimensioning when you do not have them, it means that when the moderator gets to your school, you're going to lose those marks that your teacher would have given to you. Alright, you can't get the marks if you don't have it. It's either you do or you don't. Alright, so that's something to pay close attention to. So if this is a SBA piece for you, this would be a good guide for you to complete this here. Alright, don't forget to add the title at the bottom and the scale. Now remember, the scale for all mechanical drawing or simple drawings like this, the scale is always 1 to 1, or that is what is expected of you even in your CSEC exam when you're doing your mechanical drawing. Alright, now I like to make my scale half the current size of the title or half the size of the title. So in this case, I'm just going to make it 4 and just neat things up a bit. And that is your hypocycloid. That's your hypocycloid. Alright, now this wasn't so bad, was it? Fairly easy. Alright, so that is how you create a hypocycloid in AutoCAD. If you found this video helpful, please ensure that you subscribe, alright, and ensure that you're sharing with your friends. Don't herd these valuable information and these techniques and skills and bunch of other stuff that I'm sharing here